Okay, so in this video I'm going to do just a quick overview of using TinkerCAD with the Arduino. A review really from what we did in class on our last day before the break, but hopefully this is a kind of just a good way to kind of get oriented using TinkerCAD and the breadboard and the Arduino, and kind of the foundation from which we'll start building some projects. So, one of the things I should have pointed out on the last screen was that TinkerCAD, of course, is multiple tools, and so there's the 3D design tool, the kind of the original tool that it was. So if you end up kind of there, you kind of just have to go back and click on circuits, because I'm under circuits now to kind of build something using the Arduino. So I just grabbed a small breadboard, and I'm going to grab an LED. And if you remember from class, we used a resistor, and that was a current limiting resistor to prevent the LED from blowing up, virtually blowing up. I'll actually just grab a battery while I'm at it, just to kind of start somewhere. This kind of was our starting point in class. So I'm just going to throw these down on the power rail, because it's always a good idea to have the power rails hooked up. It kind of makes it a little easier for bigger circuits at least. But and of course this is the positive terminal, so you have to remember that the LED is a semiconductor, and it only wants to pass electricity in one direction, conventional flow from positive to negative. So I'll just do a couple of quick colors here. So so we have conventional flow, we have positive of the battery connected to the power rail up to this column here. You'll remember all of these columns are connected together. They don't jump the gap, so they are not connected to these. So these are connected to this resistor. I think I made it a 330 ohm resistor, 330 ohm, not 330 kilo ohm. And that's connected to the positive of the LED, which in turn is connected to the negative and back to the battery. So we should see that light up. And of course, that resistor might be just a bit too low in its value. It's hard to know what the proper value is, given that we don't really know what the current is expected on this LED. But anyways, there's a simple circuit, and that's a good warm-up. If it's been a while since you tried TinkerCAD, then that's a good warm-up to get you started and remind you how to use the breadboard as well. So I think, a simple circuit like this doesn't really need the breadboard, but the reality is that we want to get building some more complicated stuff pretty quickly, and so that's probably going to require a breadboard. Now TinkerCAD, they used to have a schematic view on TinkerCAD, which was really helpful, because there are times when you think things are connected and they aren't, and it's just can be really difficult to figure that out. So, just as a quick tip, I've connected the 5 volts to the power rail. I'm replacing the power source now with the Arduino. And if I'm not sure if it's connected, one way to kind of puzzle that out is just to pick something up and move it around, and just see that the connection is still there. Like if I just kind of missed, I'm not going to be able to do it now, but I'm also clicking as I put these down. If I can just kind of get it close enough that it kind of seems like it's connected. I really can't, because I'm not kind of ending the connection anywhere. Anyways, I've seen it happen before where something appeared to be connected. It was so close that we couldn't tell the difference, and yet it wasn't. And so picking it up and moving it around is one little way to kind of double check that. Okay, so I've kind of replaced the power rail with the 5 volt source off of the Arduino, and that's still lighting up the LED. And of course, the real power of the Arduino is that it's a microcontroller, and that we can, run code on it. We can control things. We can light up this LED using code. And so that's where we really want to go with this. So really powering it from the the 5-volt source isn't really the intention here. We want to power it from a digital pin. So, this is kind of my intro to the Arduino, so I'll just say that the digital pins are a way to interact with the world, the outside world, and we can do that both using them as an output. So digital pin as an output allows us to turn things off and on. So it's almost like we have a 5-volt source here on each of these digital pins that we can turn on, where we provide 5 volts to, say, light up an LED, which is what we're going to do now. So I'll grab pin 2. Pins 0 and 1 are kind of special. Well, they are special, and you should avoid them. Avoid using them until you really need to. So there's me connecting pin 2 to the LED. So I know this circuit works because I've already tested it using the battery. I think that's a really good strategy, because when we work with the Arduino, it can get complicated. We could have a problem with the circuit. We could have a problem with the code. We're about to look at the code right now. And it's hard to, isolate and solve problems when we're not sure where they exist. So it's always a good idea to have a way to assert that something is working properly, and that's useful. This power source that is always on is a good way to test your circuit before we turn it into a kind of digitally controlled circuit that's controlled through code. So these blocks are great, but in our classes we're working with the basic C code on the Arduino. So I'll just flip it to the text mode, and you can see that we've already got a full working program here. I'm going to move this pin actually to pin 13. You can see that it's operating on pin 13. And you'll notice when I run it that the LED is now flashing. So this code manages to do some flashing for us using pin 13. So I think we'll just kind of go through that. We'll just build it up again from nothing. So there was this void setup here, and one of the important things to if you've done some processing, it would be nice to point this out. If you've done some processing, the basic architecture of a sketch or a program in the Arduino is very similar to the processing project, and they've shared a lot of ideas and resources. It has a setup, just like processing does, which runs once on the initial start. So when this Arduino first powers up, or when I hit start simulation, in this case on TinkerCAD, it will run the setup function once, and then it runs the loop function repeatedly. So this is a function, this void loop, but it also kind of runs like a while loop. There is some code outside of this that's controlling all of this. So something that's telling the Arduino initially that it wants to run setup, and then it will run the loop. And if we add some code above here, like we do in processing as well, where we might create some kind of global variable or constants, then it would run that first and then call the setup and loop functions afterwards. Okay, so we'll just go back to what the setup is for a moment. So one thing I kind of like to do when I write these is, I forgot my parenthesis last time, is to start off by writing this. These are curly braces, you'll notice. These are parentheses, not the same thing. In here would go any parameters. We're not going to deal with that today, but and we're not going to deal with why this is called void at this time, but we'll just start with this, and these are curly braces in which we put the code. And the only code we really need at this point is to control pin 13. So I'm just going to open the Arduino manual. Oops, Arduino manual, or reference manual, or just to make sure we have that open. I think it's a really good thing to have open as you're working on your code. And it's under resources, under reference. And actually, again, if you've used the processing project and their manual, it looks very similar. So we're working with the digital pin. So we're going to be dealing with digital I/O. So We'll look at that in a moment. And we also want to set up the Arduino to be prepared to send output on that pin as well. So that's the first thing we have to use is pin mode. If you noticed before, it had something called pin mode. So you can read this, and basically what it's going to tell us is that this command pin mode, or this function pin mode, will accept a pin number, and then whether it's an input or output pin. So for output, having a mode of output allows us to turn it off and on and control things. So that's going to be what we're going to use. So it's going to be, I'm going to just paste that in there. So we were on pin 13. And when you look at the manual, it says output and input. They're all in all caps. Okay, and this is C, so we need a semicolon on there. And I just kind of thought I'd hit run there for a moment, but of course it's not happy because I don't have a loop yet. So I'll add a loop as well. And this is where we're going to flash the LED. So pin 13 now is enabled to allow us to use this digital write command, which is also here. And this is the command that we use to turn it on, which means sending 5 volts out of the board, or also called high, the state is high, or low, where it's actually 0 volts or ground. It actually can accept current. We'll talk about that more later. So digital write, and again, it's following the same format. Where are parameters here? So pin number first, and then the value. The value is going to be, again, all caps, either high or low, whether we want that on or off. So pin 13, high. So we should just see it turn on. So, and then if we want to flash it, we should think about how that's going to work. So if we want to see it flashing, we need it to stay on for a moment and before we turn it off. So we'll use this command delay. Now there's lots of problems that we can introduce into our sketches by using delay, but for this starting point it works just fine. So this accepts a number in milliseconds, so this 1000 millisecond value will in fact delay for 1 second. Okay, so, and then we won't see anything happen when we run this, because of course it turns the LED on, delays, and then a moment later turns it back on. It's already on, so we don't see anything happening. So we really need that next step where we turn it off. So that is writing it low, and we delay again for a second, and we'll see it turn off for a second. So that's kind of like the equivalent hello world for the Arduino. It's flashing that LED. I'll also point out that there's a LED over here on the board, surface mount LED. This exists on the Uno in real life, so you can see that LED is flashing as well. So it's a really quick test of getting some code running or flashing an LED just as a kind of debugging tool or something like that, where you don't even have to hook up an LED. So hopefully you can kind of get that up and running, and we will work on that, extending that on our next video.